Welcome guys to today's class in practical physics. So if you are new in our channel, you're welcome. As you enjoy today's video, feel free to click subscribe, like the video, comment, share to your friends and classmates. So you're welcome. We want to discuss in this day video experiment on heat loss in a calorimeter. We want to see what we can learn from there. How to perform this experiment in a faster way. It has the objective to determine the rate of heat loss by conduction and convection. Okay? Then this is the apparatus where we have the stirrer for turning so that the temperature can what? Circulate. Thermometer for measuring temperature. The liquid, in this case, we'll be dealing with water. Lagging material, you can see how I demonstrated it. Calorimeter containing this water. There are a lot of things you need to know from this topic. You need to know that there is what we call heat energy. We say heat energy is a form of energy which causes change in temperature, which causes change of state of a matter. That means that heat energy is what is responsible for ice block to be converted to what? Liquid water. It is what is responsible for liquid water to get hot and turn to vapor or what? To turn to steam. Okay? So is what is responsible for conversion of a solid material to liquid and to gas. We also said it causes change in temperature of a substance. So it is still heat energy that is responsible for causing cold water, for instance, to hot water. Okay? So it does a lot of things. Another term we want to also look into is temperature. We say temperature is a measure of degree of hotness or coldness of a body, of degree of hotness or coldness of water. So if you are measuring the degree of hotness or coldness of a body, of water, of an object, you are saying you are looking for the temperature of it. And we use thermometer to do that. We have different types of thermometer, but that is not what we are to discuss here. These are the methods we want to use: conduction and convection. Conduction is a process of heat transfer which takes place in what? Solids. For convection, a process of heat transfer which takes place in liquid or in gases as well. Okay? And so when there is need for you to convert a particular temperature from one unit to another, please, you make use of this relationship. T degree Fahrenheit minus 32 all over 9 equals to T degree Celsius all over 5 equals to T degree Reaumur all over 4. This means you are converting temperature. When you want to convert temperature from centigrade or Celsius to Fahrenheit, you use this relationship. Okay? Let's say we have 80 degrees Celsius. I want to convert it to Fahrenheit. I'll compare these two. This unit is called Reaumur. Reaumur. It is an important unit of temperature conversion. So you just say 80 degrees Celsius all over what? 5 is equals to T degree Fahrenheit minus 32 all over 9. So you have compared this, and that means that I would like you to make T degree Fahrenheit subject of formula and use the comment box and tell me what you get. So you just cross multiply, you get 720. 5 times this, 5T degree Fahrenheit minus 5 times this, 160. And from there, you get your correct answer. So I want you to do that. and tell me what you get. So if you also want to convert 80 degrees Celsius to Reamo, you say 80 degrees Celsius all over 5. That is about this equals to T degree Reamo all over 4. You are comparing this and this. And so when you do this also, you will notice what will be the answer. Just 4 times this divided by 5, it will give you the answer, right? So also use the comment box below and tell me what you get. Okay, let's see what we can learn from this experiment. Want to see how to do this experiment in a faster way. The procedure we have is fill 2/3 of the calorimeter with hot water of about 70 degrees Celsius. Stir continuously by using the stirrer and take the temperature T reading using thermometer at 3 minutes interval. Weigh the calorimeter when empty and record the mass M1. Weigh it again when filled with 2/3 of water and record its mass at M2. So this one, weighing M1 and M2, please you have to do it. You weigh M1. M1 means when it has no water, when it is empty. Let's say we have 135 gram. Then M2, when it has water, you weigh it. Let's say we have 200 gram. That means M3 will be equals to when it has water, when the calorimeter has water minus when it does not have water. That will give you the mass of water. 200 gram minus 135, 65 grams. So you use your weighing balance to do what? To get the what? These masses we talk about. Now, what is the concept of this experiment, you may ask? The concept is that when you have a hot water, in this case 70 degrees Celsius, it is noted that the higher the time as you keep the water inside the container, are you getting it? As you keep it, as far as you are not applying heat to it, you just put it inside the bucket. Okay, as you just put it inside the bucket, as far as you are not applying heat to it anymore, just carry hot water from the kettle, pour inside maybe a cup. If you just pour it inside a cup, you will notice that in the next 3 minutes, because evaporation causes cooling, you will notice that cooling will be taking place. And what will happen is that the temperature will now be reducing. So in the next 3 minutes, we are asked to get the temperature. In the next 3 minutes, that is, you get the temperature. As the evaporation is causing cooling, the temperature must be decreasing. If at any point you get a higher temperature, higher than what you have before, it means you have encountered a serious error, and so it shouldn't be so. And so it's just what you have been doing. That is why you are trying to perform this experiment to see what is the rate of heat loss by conduction and by convection. Conduction, because a solid material is holding the what? Water, the hot water. Are you getting it? And so the solid material that is holding the water will still have effect on that water rate of what? Evaporation. The rate at which the hotness of the water evaporates, it will be affected by the what material is inside. Then the liquid itself, which is water, will also affect the rate of that heat transfer, the rate of heat loss that will be taking place. So I want to see how to do this experiment. We have said this, you have to do it. Now, for you to perform this experiment without touching apparatus much, what you need to do is to remember that there is a formula called Newton cooling curve law. Newton cooling curve law. Newton cooling curve law. This Newton Coulomb curve law says that T at a particular time is equals to T of the surrounding plus minus T of the surrounding, then exponential minus T. You have it this way. And so, what does these parameters we are seeing here, what do they mean? This T with bracket T, it means temperature of a substance at a particular time given. Temperature when it is 3, when it is 0, when it is C, that is what we call TT. Then TS means the temperature of the surrounding. In this part of the country or in this part of the world, the temperature of this our surrounding, our room temperature is between 25 to 27 degrees Celsius. My environment, this room temperature, as I took the temperature, I got 27 degrees Celsius. So in your own site, if you check the temperature of the room, of the laboratory place, you also get the what? The temperature we talk about, TS. That is the temperature of the surrounding. So I did this experiment in the room, and so I noticed the temperature of the room is TS, and so it's 27 degrees Celsius. It will have its effect on the rate of heat loss we talk about. Okay? And so we talk about TO. We say TO is the starting temperature. In this case, they say it is 70 degrees Celsius. Then we'll talk about small t is time. Then all this time we talk about, that is what is small t. Then K is the cooling constant. E is normal thing, is a mathematical term, so to speak. E means 2.718. E means 2.718. Now, how do we use this formula to get our readings, our table of value, as fast as possible? For us to use it, first of all, the only thing you need to do is to check when you pour that 70 degrees Celsius water inside this calorimeter. When you just do it, what you have to do is, as I have noted the temperature, this temperature is in degree Kelvin, that is the SI unit, but we are taking it in degrees Celsius first. We are taking it in degrees Celsius. You can also take your own in degree Kelvin immediately by saying 70 plus 273. That means to convert degrees Celsius to Kelvin, you add that degree Celsius to 273. You get this value that should be here, and change here to degree Kelvin, because degree Kelvin is the SI unit of what? Temperature. But I am just putting my result in degrees Celsius. I just decided to do so. But if you do your own in degree Kelvin, it's not a bad idea. Okay, that is by the way. Then we now say that only check what will be the temperature in the next 3 minutes. Once it gets to next 3 minutes, check the temperature. And so when we check the temperature, we have 63.00. Now, because we have gotten it, the temperature of the first one, instead of us waiting till the next 3 minutes before you get this, in the next 3 minutes before you get this, and others, this one is 3 minutes. In some experiment, they can say in the next 5 minutes, in the next 10 minutes, and so you will now see that you spend much of your time trying to get the table done. So what you need to do is take this one you have gotten, and put it in this formula. Once you put it in this formula, whatever it gives you as value of K, note it. I repeat, whatever it gives you as a value of K, note it. Okay, let's do that. Okay, the first thing we do is our TT is the temperature we got. We got 63 degrees equals to our TS. We say that our TS is 27. This is the temperature of our room environment. Are you getting it? Yes, so that one is constant. It depends on the temperature of the working environment, the surrounding where you are performing this experiment. So you need to get the temperature noted. Okay, so I checked my own and it was 27 degrees Celsius. That is why we are using that. Plus bracket the 70, which is the temperature of the starting temperature. This is starting temperature, this 70 degrees Celsius, minus the temperature of surroundings, 27. Then exponential. This exponential means 2.718 raised to the power of minus k t. And so what you do is that you will say this go here. You will be having 63 minus 27 equals to this minus this will be giving you 43 degrees. 43 bracket 2.718 raised power minus k t. And what is your t? Your t is the 3 minutes. The 3 minutes. Okay? And so 63 minus 27, you use your calculator to get it. 63 minus 27, you have it to be 36. Then you now say all over 43. All over the 43, it will be giving you 2.718 raised to the power of minus 3k. Here, remember that 2.718 is what is equivalent to E. And so, opposite of E in mathematics means lane. And so, for us to take care of this, for us to bring down minus 3k, we take lane of both sides. Therefore, taking lane of what? 36 over 43. The lane of 36 over 43 is equals to, when you take lane of here, you have minus 3k lane 2.718. You have minus 3k lane 2.718. Lane times 2.718, they are opposite, so they will take care of each other. Lane times this is equivalent to 1, so they will clear out. And therefore, we now say that our k will be equals to lane 36 all over 43 in bracket divided by what? Divided by what? Minus 3. That will be your value of k. Let's get its value. We say lane bracket 36 divided by 43 divided by minus 3. So the answer will be 0.0592. So we say that our k, we'll write it here, that our k is equal to 0.0592. 0.0592 per what? Per minute. Per minute. We said per minute because unit of time is a minute. Now, after we have gotten this our k, it means now that we use this formula to do what? To get for next what time. That means I'm not going to be checking my temperature again, performing those experiments. I'll just sit down, use my calculator and run it down. Okay, let's see how to run it down. Okay, for the first one at 6 minutes, I will say that the temperature will be equals to Ts is 27 plus 70 minus 27. That will be giving me 43. Then bracket 2.718 raised to the power of minus 6 times. Raised to the power of minus 6 times. What is your K? What is your K? 0.0592. You just use your calculator to compute it. I'll just say 27 plus bracket 43. Let's check this first. 2.718 raised to the power of bracket minus 6 times 0.0592. Whatever it gives you times 43 plus 27. We'll be getting 57 degrees. We have it to be 57.10 degree Celsius. Okay? We write it here. 57.10 degrees Celsius. Please, you don't write degrees Celsius continuously. Just this one will take care of it. You change here to what? 9. That is just it. You just say 2.718 raised to the power of bracket minus 9 times 0.0592 times 43 plus 27. You will be having 52.2 degrees. So for the one of second T, we'll be having 52.2 degrees. You write 52.20 degrees. Yes. You come here, you change here to what? 12. When you change it to 12, you take it again. 2.718 raised to the power of bracket minus 12 times 0.0592. That will be giving you an answer times 43. You have it plus 27. That will be giving you 48.1 degrees. You have it to be 48.1 degree. So you write 48.10 degrees. You do that one for the one of 15. You change here to be what? 15. You change it to be 15. You'll be saying again 2.718 raised to the power of bracket minus 15 times 0.0592 times 43 plus 27. That is 44.7 degrees. You say 44.70 degrees. Wow. You can also do this approximation to nearest whole number. Are you getting it? But once you do to nearest whole number, you continue that way. Okay. We go again. Change this 15 to what? 18. 2.718 raised to the power of bracket minus 0.0592 times 18. You'll be having it to be this times 43 plus 27. You'll be having it to be 41.8. Okay? You go again. and change this time to what? 21. You change the time to what? This is 41.8. You change this to 21, you go again 2.718 raised to power of bracket 21 times minus 0.0592, then times 43 divide plus 27. That will be giving you 39.40. Okay, so you see we have been able to get our whole temperatures at this point without what? Continuing checking with our what? Thermometer, without checking for the one of 6 minutes with our thermometer. In the next 3 minutes, that is 9 minutes, check again to get, without embarking on those unnecessary protocols. So with this, you can just sit down and what? Run your experiment as fast as possible. Now we have seen our table of value. You can convert it to Kelvin, to Riamo, to Fahrenheit, depending on the temperature you want to use to do your what? Graph plotting, or the temperature instructed for you to do your graph plotting on. I get it, but I decided to keep my own in Celsius and run whatever calculation, so to speak. They say plot the graph of t against time. We will show you how to do the graph plotting. Yes, because once the graph plotting didn't go in terms of curve, you are wrong against time. So it must be in terms of curve. If it is not in terms of curve, you are wrong, because we say Newton Coulomb curve law. So the graph is obviously a curve, so to speak. We'll show you how to do it. So keep in touch with our channel so that you see when we get the video uploaded. Just click subscribe. It will not take you money. Click like, comment, use all the options there. Are you getting it? You feel free to use those options and enjoy your. If you have any topic you want us to discuss, you can also let me know there. Okay, feel free to subscribe, share it to your friends so that them too will learn as well. Now let's check this question. Determine the time taken for T to fall from 65 degrees Celsius to 55 degrees Celsius. Now for you to solve that question, I can get it after plotting that graph. So when I plot the graph, I will also show you how to get it. When I plot the graph, I will show you how to get it. Yes, but the summary of it is that if you plot the graph of temperature against time and it goes like this, obviously it must go like that. What you do is that go to the temperature axis. This is temperature and this is time. Go to the temperature axis, locate 65 and trace it to the curve. Trace it down. You say your T1, T for that one on 65. Also go to the graph, locate 55. You call it T2. That is for the one of 55. Now, note the difference between the temperature. Modulus of T2 minus T1. Modulus means the answer must be positive. So this is in terms of time. Modulus of time 2 minus what? Time 1. Whatever it gives you will also be in minutes. Please remember that this unit you see us attaching, the answer to the question number 3 will be in minutes. That is when you get it from the graph. Okay, so be careful as you do the extrapolation so that you get it correctly. It will be in minutes. That is in case you are in a haste, you want to get everything in this video. Please just sketch the curve. After plotting the curve, just locate 65, trace it down, get the first time. Move again. This is 55 and this is 65. Locate 55, trace it down. You get your T what 2. And you get the difference of the time. You get it in what? Minutes. Okay? That will become your answer. But let's see how we can get it using formula approach. Yes. Yes. We don't like to stress ourselves so much. Okay. To solve it, we say TT. That means that we are looking from 65 to 55. Okay, so here will become your 55. Yes, and here is your 20 what 7 degree, the one we call the surrounding temperature, plus 65 minus 27. Are you getting it? Exponential, where the exponential is 2.718, then minus 0.0592 times t. We are looking for t times 2, t, so to speak. So this goes the other side. We have 55 minus 27. What will it give us? We have it to be 28. This minus this 65 minus 27. What will it give you? 38. This one will give you 38. So 28 over 38 is equal to, what do we have here? 2.718 raised to the power of minus 0.0592t. Okay, we are now to make the subject of formula. Take ln of both sides. We have ln 28 over 30 what? 8. Now, taking ln of this one will make this to go. So, when you take ln of here, it means that what you will be having is minus 0.0592t. Therefore, my t will be equal to, let's get ln 28. Ln bracket 28 divided by 38 is equal to minus 0.3054 all over minus 0.0592 divided by minus 0.0592. Okay, that will be giving us 5.2 minutes. 5.2 minutes. That means if you go to the what? To the graph and you try to extrapolate, you are trying to deduce this value of t, time taken for it to fall from 65 to 55, the answer should fall around 5.2. If it didn't fall around 5.2, you are wrong. So check it out well. I've told you how to do it. Just after plotting the curve, this temperature against time, this is 65, trace it down. This is 55, trace it down. So get the difference between their what? Temperature, between their time. Get the difference. That becomes your answer. I believe that this experiment you learn something there, because we have been dealing with this in our daily life, but we do not know that it's part of what we have to discuss in physics. And so if you find this experiment interesting, if you enjoyed it, please don't forget to click subscribe, share to your friends, comment, likes, enjoy it as you like. Okay, thank you again for watching this video. See you in the next experiment.